about concrete, reinforced concrete, the problem of cracking, and finally the technique I use to analyze the crack. I'm sure that all of you or most of you know that concrete is a construction material. Actually, it is very ancient construction material. This is the Pantheon. This was built hundreds of years ago using concrete. And the amazing thing that it is still standing. So concrete performed well in the old structures. But with the development of structures became more complex in terms of the shape, the height, the structural frame. So there was a need for another material with maybe higher strength. So the steel was a good alternative. During the last century, many of the buildings was built using steel. And the World Trade Center was one of the examples. Most of the structural elements were built using steel. But after the 11th of September attack, the behavior of steel with high temperature, under high temperature, was questionable. Although there are many theories to explain the collapse, but it is believed that the reinforced concrete core in the center of the twins played a vital role in postponing the collapse and saved thousands of lives. So this was the turning point that, and this brought to attention how the properties of concrete are amazing, but we need to work on the drawbacks in concrete. Just one example is the Trump International Tower. The design before the attack was ready as a steel building, but immediately after the attack, it converted completely to be concrete, mainly concrete structures. So the last 10 years acted as a new era for concrete. Extensive research were done and still being done. We can distinguish between the different researches in this area by saying that this can be divided broadly into two fields. Working on the material itself, like the composition, the cement as the first presentation we had today, or the reinforcement we used in the steel, and working on the structural behavior. So in terms of structural behavior, enhancing the structural behavior and studying the shortcomings and try to overcome the shortcomings in reinforced concrete structures like cracking. And actually, this is my field area. So this takes us to my research aim, that I am studying the crack propagation in reinforced concrete structures. To do that, small-scale reinforced concrete beams were cast using different reinforcement ratios, different concrete mixes, and we tested them under loading to monitor the crack propagation. Why did we do that? Because we want to have a deep look at the cracks, study how the reinforcement below try to bridge the crack while it's propagate, and to study the fracture burst zone ahead of the crack tip, which is very critical in terms of the ability of the crack to propagate. But how did we do that? How can we monitor the crack? We use simple technique. It is the digital image correlation. Digital image correlation just need camera, analysis software, and high precaution in terms of light, stability, and other things. So the simple concept behind the digital image correlation, that different images are taken under different loading conditions. And using some correlation algorithms, each pixel is tracked through the images. And by this, we are able to construct full visualization of the crack, construct the strain profile around the crack, and also we are able to study how the crack develops in terms of the opening and the length with loading. So the results I got so far, that the DIC seems to be very effective in terms of monitoring the crack, and if we work on this, we can use it as a technique to monitor cracks in bridges or other things. And we found that the surface between the steel and the concrete play a vital role in the crack propagation. And we found that the crack propagates at the beginning, so the width and the length increase. But after that, there is some rotation around the crack tip, which should be reflected in theoretical models and in design regulations. That's all, finally, without any cracks. Thank you very much for your attention. Thank you. Okay, yes, I will be happy to answer them. Any question?
You put concrete, you put fibers into it, cement or not?
No, I'm studying reinforced concrete with bars. So fiber concrete is concrete. The fiber is one of the composition of the concrete. But I use isolated bars. This is the common system to be used around the world. Or you mean fiber reinforced polymers as reinforcing bars?
That is one stage, yes.
Yeah, until the moment not, but we will use it in the coming stage of my research. So the first stage is to work on steel and study how the mechanism of cracking with steel and compare it with other options like the fiber reinforced polymers.
This seems like such an important topic. Why has it not been studied before?
Yeah, it was studied, but you know, with the developments of imaging and image processing, we can have more in-depth looking at the cracks. So we can identify new critical parameters that control the mechanism.
And could I ask another? I mean, my guess would be that once a crack has formed and is sort of visible,
yeah.
You've had it. It's kind of it's the precursor, and it's the micro crack which is so important because that is telling you the problem. Can you study those, you know, as the crack is just forming?
Yes, the image is very big comparing with the actual size of the crack, but all of us should know that cracking is something that should be in the beams. So any beams, you can see it has cracks. So because the concrete is very weak in tensile, so the regions where there's tensile stress, they have cracks, no doubt. So when this problem is critical, this is maybe the issue that I want to study, the transition between being it's normally cracked and being critical, especially in assessment of old buildings, maybe one of the applications.
I hope the bursar is reassured by this.
Yes.
Yeah, most bridges have lifetimes 50, 60 years. What would you estimate the lifetime of a modern skyscraper building, 100-story?
How can I estimate, or?
Could you give an estimate in centuries?
The matter is the estimation of the reinforced concrete structures. So even for skyscrapers, bridges, the matter that you will check each element. So it's not a problem that if you can check or not the skyscraper. It's simply a reinforced concrete building. Each element should be checked. So hopefully I can find some criteria that enable us to assess these elements. So if you assess each element and the overall behavior, skyscraper like another building. So it's a matter of
software to develop.
Software?
Yeah, you could market that software.
Ah, yeah, I hope that. Thank you. Thank you very much.